So welcome everybody, thanks for coming. I'm delighted to see that we've got a good turnout so far. So I'm going to start by drawing our attention to the fact that we're standing on the land of the Wurundjeri people of the Kulin Nation, who are the traditional custodians of the land that we stand on. So I want to pay my respects to their elders past and present. So the Australia-India Institute holds this question mark seminar series to focus on key global questions and problems through an Indian lens. So we do this through 4 sets of question mark talks on the 4 themes of the work of the Australia-India Institute. Those are health, education, governance and security, and infrastructure. And this talk is from the infrastructure theme. This talk is also our second event as part of the Australia-India Institute's India Week of celebrations, of which we have a whole load of events happening this week. You can look on the Australia-India Institute's website, and please do sign up to any of those that are taking place in the next few days. So this week we're going to be addressing, tonight we're going to be addressing the question, how can smart technology make India's environment cleaner? And I'm really delighted that we've got a couple of speakers from UNSW to talk on this topic today. So firstly, we're going to hear from Dr. Komali Yenneti, who focuses in her work on contemporary environmental policy and projects. And in particular, she looks at smart cities, low-carbon urban development, and energy transitions across cities, regions, and communities in the Asia-Pacific. After we hear from Komali, we're going to then next hear from Dr. Vaibhav, who works on the development of composite fabrication technology from recycled wood and plastic. He also looks at e-waste recycling, waste characterization, and life cycle assessment. So he's going to talk after Komali. They'll both talk for about 8 minutes each, and then we'll have some comments from our 2 discussants today who are going to reflect on what has been said and ask our 2 speakers or challenge them to talk in further detail on, and also to challenge them on the key question that we have today. So we've got 2 discussants, Dr. Meenakshi Arora, who is a senior lecturer in the Department of Infrastructure Engineering and is director in the Melbourne, India postgraduate program. Dr. Arora has extensive experience in water resource management research and teaching, and her main research interests are urban water cycle modeling, water quality, contaminant transport modeling, and stream health. And joining her, we have Professor Robin Jeffrey, who has forged a distinguished career researching and writing on the modern history and politics of India. Most recently, he's written a well-acclaimed book on waste in India. So I think his reflections from that book might be informing his discussion tonight. Before we get into the speakers, I just want to quickly introduce the question and why this is such an important question to be asking at the moment. So over the last couple of decades, India's seen, as we all know, dramatic growth in GDP in the last 2 decades in particular. So the economy has grown massively. This has had huge benefits, obviously, in terms of lifting millions of people out of poverty and in terms of the development that India's seen in the last 2 decades. But the other side to this is that it has introduced challenges in terms of pollution that India is now beginning to see and is going to have to be facing in the coming years. So I've just got a couple of slides to focus our attention. We'll see, recently there's been a lot of reports on the most polluted cities in the world, and we see that India represents 14 of the 20 most polluted cities in the world if we look at PM levels. And so it's a very serious challenge. Often we think of Beijing, for example, as being the most polluted city in the world. This is a stereotypical example, but actually Delhi and other cities in India have even greater challenges on that front. India has huge challenges in terms of waste and how it deals with waste. So I just took a couple of statistics that kind of highlight this problem. India generates 62 million tons of waste every year with an average annual growth rate of 4%. It generates 100,000 metric tons of waste per day. And at the moment, a lot of that waste is recycled or disposed of in within the informal economy in ways that produce all kinds of environmental challenges. India currently has the capacity to treat approximately 37% of its wastewater, and the rest of that flows into streams and rivers, which poses huge environmental challenges. Of course, as the world faces the problem of climate change and increasing temperatures, this is a particular challenge to cities in India, which are already extremely hot. And there's questions of how a city is going to be livable in the coming years as climate change sees temperatures rise. So those are just a few introductory thoughts. And without further hesitation, I'm delighted to welcome Komali to talk on the topic. Yeah. Do you want to sit down?
Thanks everyone for coming down, and thanks for that kind introduction. And I think it's already a lot has been talked about climate change in the last several years. But I just want to start with one question. How many of us actually know what's smart or smart technologies? Does anybody has an idea of what is it, a smart technology? I know it's a question mark series, but I actually want to start with a question. Right. Yeah, but when we talk about smart technologies, we often end up discussing IoTs, or Internet of Things that we call, or largely based on Internet or Wi-Fi based technologies. But we forget often that smart is something which is sustainable, measurable, applicable, relevant, and time-based, which is SMART. So it's really important to see that any technology that sort of comes into all of these addresses, all of these sort of indicators would be relevant or largely a smart technology. Having said that, my work is largely based on looking at smart cities in the Asia Pacific, especially looking at climate change or increasing temperatures. And we already know that India has been, over the last decade or so, the maximum temperatures that we found in 100 years is just in the last decade. And one of the major work that we found from our own research is that the top 20 smart cities, which is under the Smart Cities mission, I don't know how many of you in this room are aware of the Government of India's Smart Cities mission, which aims to propose like 100 smart cities. But can this be really achieved when the cities are already facing enormous number of challenges related to climate change and other environmental challenges? In the last decade, in the last century, India has witnessed increase in annual mean temperatures by about 0.6 degrees centigrade. And future projections also shows that the average annual temperatures are expected to increase by 0.6 to 1.5 by 2030. And in the worst case scenario, by 2050, this is going to be up to 5 degrees centigrade. And we already know that the recent IPCC report came up at 1.5 degrees report, and it actually said that the maximum, the countries which are going to be most impacted are in the developing countries in the Asia Pacific region. So, but that's not all gloomy. We have a very interesting and new technologies that can provide innovative solutions to this issue. And some of these I'll not touch everything today given the time so I'll just talk about two important areas. One which is into solutions that decrease absorption of solar radiation or release of heat to the atmosphere and keep our urban surfaces cool. And the second one would be technologies that increase evapotranspiration in urban environments. That includes water-based systems, and we already know urban greenery, but there are more innovative technologies that will come up. So in terms of water-based urban landscape, we already know that there's a lot of, for centuries, water has been an important source for heat mitigation or cooling. But in the recent years, there's been innovative technologies, including evaporative wind towers, sprinklers, and water-based fountains, which provides urban ambient temperature reduction up to 3 to 8 degrees centigrade. And in terms of urban greenery, there's a different forms of natural and design urban greenery, such as we already know the general kind of stuff that like urban parks or trees, street trees, open spaces. But we don't know that this can provide urban temperature reduction up to anywhere between 3 to 5 degrees temperature Celsius. But in the recent years, there's also been extensive research, innovative technology, and also applied research being in many countries around the world, including India, such as green roofs, vertical gardens, and also breathing walls. There are examples that's been implemented. For example, in Sydney, One Central Park building, I don't know how many of you know, I've been seeing that. That's one of the best examples. We also have that sort of green walls, breathing walls are used around the world, including Singapore airport, and also in India recently, a number of railway stations are adopting this. One example, which was done in Ujjain, this was undertaken, and the research findings shows that the green walls can actually provide temperature reduction up to 5.5 degrees centigrade. Having said that, there's also new technologies apart from the green and water-based technologies. One of the most important things that we are doing in our own research is reflective materials, which are also called cool materials. Advanced cool materials with high reflectivity and high emissivity are now commercially available. The common cool materials are mostly we see like white, and they are either polyurethane coatings or elastomeric coatings. I'll not go a lot into technology, more of the technological side of it, but cool materials are found to be one of the most innovative technologies for reducing heat at building level, not just also at building level, but also for cool pavements. City of Sydney has recently implemented a sort of a project for an entire street level pavement paving all white. And also there's a number of other examples around the world. One of the examples in Australia we have is White Gum Valley in Adelaide. That's one of the best examples. There also, in the recent years, we have also undertaken a number of projects on cool materials. And from our research, we have also developed groundbreaking research on colored materials, because we know that we don't want our walls and roofs to be painted white. We like colors. So we have developed materials that can turn white in high temperatures or high during the day and can become normal during the night. So that's one. And we also have a lot of research that's been done in terms of developing other materials, such as including water retentive and permeable materials. Photovoltaic based pavements, there's been done around the world as well. And experimental research specifically in India suggests that cool materials can contribute to about 2 to 5 degrees temperature. These sort of materials can also help in indoor temperature reduction and also reducing energy use in air-conditioned buildings. And we know that one of the major contributions to urban heat is actually air conditioning. But having said that, I also want to say that technology are not simply absorbed and implemented through either just one-off policy or by one person. Relevant policies that bring together community, industry, and government are crucial for wide-scale implementation of these disruptive climate-smart technologies, and then integration into the mainstream urban policy. Just to touch on that, so I'm based at the High Performance Architecture Research Cluster at UNSW and the CRC for the Low Carbon Living. So at both of these, we are developing a number of projects, including one of the projects that we're doing is Citizen Science Project, which is actually engaging communities, public, and school children with the technologies that they can use in their own communities to measure temperatures and also sort of get an idea of what's happening in their own communities. There are also a couple of projects that we're doing. One is cool roofs in low-income communities of India, and this project was carried out in the last 1 year, and we're actually planning to take that to Australia next year, potentially in low-income communities or in Australia. We also currently developing a project which includes developing a new decision support tool to help urban policymakers and governments in their own decision processes while development approvals or other related areas. Just to pick up on that, I think these are all great examples of how partnerships can sort of promise more livable, sustainable, and smart cities in India and also in Australia. Thank you. Just on that point, I'm actually currently leading a project on Australia-India Knowledge Exchange Series. They're going to be like 4 workshops. So one is actually on the November 16th in Sydney, which is on PlanetMath cities. And we have a range of speakers coming from India and also Australia. And 2 events are going to be one in Delhi in December, one in Hyderabad in December. And then other one in early next year in March. So if there's anyone interested, yes, please get in touch with me. I'm happy to share with that. Thank you.
Thank you. So without further hesitation, let me introduce Dr. Vaibhav Gaikwad, who's going to talk for a little while.
Thank you. Jonathan.
Should just be behind. Yes.
Good evening, everyone. My name is Vaibhav Gaikwad, and I'm an NG and a New Generation Network Scholar at the UNSW, University of New South Wales. And in the next couple of minutes, I will endeavor to answer the question, how can smart tech make India's environment cleaner? But that in context of electronics waste. So how can smart technology enable India to lighten its electronics waste burden, and thereby making it contributing to a cleaner environment in India? The reason for selecting e-waste as a topic for today is multifaceted, but mainly e-waste is the fastest growing waste on the planet, grows at 4 to 5% per annum, and it is also one of the most hazardous wastes on the planet. But one of the distinguishing things about this waste is that it also contains a lot of valuable materials. So precious metals, base metals, plastics, glass. So it's a very diverse type of waste, and it is very challenging to recycle. And it is one of the major challenges that India faces currently and will face even more in the coming years. So India produced almost 2 million tons of e-waste in 2016. Globally, the number stands at close to 50 million tons per annum, and it's growing. As I said, it's around 3 to 4% per annum. So there is despite all the technological developments that have been there in this sector, there is still a gap between what the technology can and cannot process, or more so what people want to process with that technology. And this is the gap where the smart tech or the smart technology can fill in helping India address its e-waste burden. But before we go to that, like Komali almost spoke, thanks for introducing the smart technology thing. But one thing which I'd just like to take a step back and introduce as to what the terminology smart means in terms of waste recycling. And I think, so this, just to put it into perspective, this is a picture of a very old steam locomotive. In 1800s, this was smart. So that's the smart tech for 1800s. Not today. Today, the smart thing is electric vehicles, electric locomotives. The point being, the definition or the terminology of what smart actually constitutes changes with time. So time is one factor, and the other factor is the context. So in terms of, for example, electronics or communication, you'll have your smart watches, smartphones that enable people to talk with each other, communicate with each other through wireless internet, and other networks like that. So that is what we are accustomed to here when we say smart technology. But in terms of waste, in terms of waste recycling, I think there is a need to broaden the scope a little bit further. And the reason for that is recycling, usually any type of waste, the recycling process consists of three main stages. So you'll have the collection, then you'll have the sorting, and then you'll have finally the processing or the disposal of waste. And each of these sectors will have a different type of smart technology associated with them, or can have a different type of smart technology associated with them. So for example, if you talk about the collection, so there are now these smart bins that even India has started to implement, wherein there are various sensors that tell how much of waste is being collected. If some waste bin is about to be filled, they can then communicate with the company or the municipality who's about to pick up the garbage, saying that no, this one has to be picked up first, this one can wait, and things like that. So that's smart technology in the collection side. Smart tech on the sorting side, and this is where a lot of developments have happened recently. So separating metals from the waste is pretty normal. But now there are completely automated machines that can not only separate the metals from plastics, but distinguish between different types of metals. They can also distinguish between different types of plastics, not just based on their color, but based on their types. So this is another example of smart tech. But I will mainly be focusing on the downstream, so the processing or the disposal of waste. So what smart technology actually means in that. That's because that is where my research lies, and I have some experience in that. So I'll be focusing mainly on the downstream part. So for me, smart tech in terms of waste processing or waste recycling is essentially any technology that can enable improvement in the current scenario, not only by the means of automation, not only improve its efficiency, but also its end use. So for example, incineration and landfill are two of the most widely utilized waste disposal techniques for almost all types of waste in the world. Now, we don't want a smart tech that is going to say that, okay, this is how we can improve the efficiency of landfilling. That is not the end game. The end game is actually to have a smart technology that can transform or convert waste into a completely different product that is of a higher value than what you started with. So the end product has a higher value than its feedstock, and that technology can do so, can manufacture that project in an environmentally and socially responsible manner. So essentially, it should be able to deliver the triple bottom line. So that is what smart technology in terms of waste recycling should mean, or at least what I think it means. And this is where. So coming back to e-waste, now talking about the smart technologies that we are developing and that can be implemented in India and how they can help India to overcome its e-waste burden. I think India needs to have a mix of technologies. Given the amount of e-waste and the type of e-waste that is being generated, it is the most dynamic waste on the planet. Just imagine the amount of technology that is developed. We are throwing in our phones at a faster rate than ever. So it's a very dynamic waste. It keeps on changing. So to account for that and the volume, India needs a mix of smart technologies. So we can divide them into two broad categories. One is the established smart technologies, and the other is emerging smart technologies. And the established ones, as of today, focus more on the metals that are contained in e-waste. So e-waste, as I said, contains metals, glass, plastics, and heaps of other types of materials. But people are more likely, or the technology is more focused on extracting the metals, just because there is more economic value in it. People need to make money, and that's why the technology is more focused on extracting precious as well as base metals. So precious metals like gold, silver, palladium, platinum, and base metals like copper. So there are technologies that involve hydrometallurgy, that is involving use of chemicals to extract metals, pyrometallurgy, which is heat to extract metals, or a combination of these two. And these are all established technologies. There are companies like Umicore or Glencore who have this technology and are doing it across the globe. Even in India, we do have small-scale players in the formal sector that are doing this in an environmentally responsible manner, but they cannot match the scale of the waste that they get. So these are very, very small players. And I believe that India as a nation needs to invest on these established technologies wherein the know-how is abundantly available. These technologies can be readily implemented So it's all about licensing, and it's all about getting the technology from people who already. I'm going to use a cliche here. So we don't want to reinvent the wheel in these sort of technologies. So they're already there. We need to implement it. So it needs to be on the scale that can take care of the immediate need for e-waste recycling. And then we can move on to the emerging smart technologies. So the emerging smart technologies can focus more on the low value components of e-waste. Plastics account for almost 15 to 20% of e-waste and are often the most neglected component of it, simply because there is not much economic value in extracting plastics from e-waste. So as I said, smart technology should be able to give a higher value product compared to what it started. And that's why these sort of technologies are emerging. So there's still a fair bit of an R&D that has to go into it, and a lot of development needs to happen. But having said that, we are doing some interesting work at UNSW. So my team and I, we have come up with different types of technologies that can enable transformation of plastics into different types of higher value products. To start with, so this is one of the papers which was recently published, and we do have a pilot plant of this technology running in Sydney at UNSW. So what this technology does is it takes e-waste plastics and converts it into filaments for 3D printers. So like conventional printers, 3D printers also need ink, and that ink is in the form of a filament, a string of plastics that can be used as an input for the 3D printers. And it takes care of all the, so it can process mixed plastics as well. And in doing so, what we have done is, reduce the CO2 emissions for making these filaments by 30%. Instead of using virgin feedstock, virgin materials, we have utilized e-waste plastics and managed to get the CO2 emissions down by 30%. And also in the process managed to create a higher value product. So this sells for almost $30 a kilo. So that's compared to what scrap plastic would sell, that is a huge increase in the amount of revenue any company that is looking to invest in these sort of technologies would generate. So that is one example. And the reason why e-waste plastics are so complex to be handled or to be recycled is because of the presence of persistent organic pollutants, or POPs, also known as flame retardants, brominated or halogenated flame retardants. And in our technologies, we keep that in mind, and our IP, our technology is developed keeping all of these things in mind as to to adhere to the different conventions that are there. So we keep all of that in mind and developed our technology around that. So that's one example. The other example is based on toner, waste toner. So I'm not sure if you guys know, but there are almost 500 million toner cartridges discarded or landfilled every year across the globe. And 8% of that toner cartridge, weight of the toner cartridge, is your toner powder. So just imagine how much of toner goes to the landfill. Now that's not only hazardous for the environment, given the chemicals that are there, but we also waste a lot of resource by putting in toner in landfills. That is because toner contains almost 30 to 34% of iron oxide. And so what if we wanted to extract these type of metals from the toner? And we've come up with a technology that can actually do that, and using no added extra source of carbon. It can use the carbon that is present in the toner itself and convert the iron oxide to iron, reduce it to metallic iron. And this is now being incorporated in a plant in Sydney. There's a pilot plant running with our industry partner, and this is in conjunction with e-waste plastics. We make a product with it that is then going to be sold to steel manufacturers. The beauty of this process is the end user doesn't have to make any change at his place to use this product. So this is what, again, this is an example of a smart technology wherein your end user doesn't have to make any added investment in his infrastructure. He can use the same infrastructure, get this product made from whoever is manufacturing that, and use it straight away. And finally, one of the other examples is, so this is a supercapacitor, so an energy storage device. We've produced activated carbons from e-waste plastics, that can be utilized as to store energy. The next part of this research is going to be to create materials, electrode materials, to store as battery materials for lithium, sodium, and lithium sulfur batteries. So again, utilizing a waste material, a very low value material, and converting it into a higher value material that can be used in various applications. So that's just some of the examples of smart technologies which can be deployed in India as well. The reason for that is none of these technologies require specialized equipment. So they're all the equipment required for this, or the infrastructure required for this, can be brought off the shelf. And so the investment or the capital required for these type of technology, depending on what technology you choose, is also varies, but it is definitely applicable in India. And so these type of technologies, if they function in tandem with the existing or the established smart technologies, they can provide a much better outcome and help India for getting a much cleaner environment. So that is what I wanted to convey. So thank you very much.
Thanks very much. So maybe you will want to just stay at the table now, and I'm going to invite first Meenakshi Arora to give a few comments and feedback, and then I'll invite Robin Jeffrey to do the same. Maybe you can both, one after the other, give your thoughts, and then it gives a chance for Komali and Vaibhav to have some thinking about it and to respond to what you've said. And then after that, we can open it up for questions to the audience.
All right, thank you, Komali and Vaibhav, for very insightful presentations. So Komali, first thing, I just wanted to say that you have mentioned about the impact of climate change on getting more extreme heat waves, and we are experiencing that everywhere. Australia is no different than India. And you proposed two main sets of solutions. One was about the materials you are producing, and the second was about WSUD, water sensitive urban design and green infrastructure, which relies on use of water to cool down the cities by increasing evapotranspiration. So my question or my comment is, for the same reason of climate change, we are also seeing reduction in rainfall and also variability in the rainfall. We are seeing more extreme rainfall events, most of the rain falling in small and shorter duration of time. So we have a lot of water available at one time of the year and none at the other. And your water-based solutions rely on use of water to get those green infrastructure going. So have you had any thoughts on, in a water-scarce environment, specifically in India, how do you manage the urban heat island effect, which requires more use of water, while most cities are struggling to meet the demands for urban as well as agricultural sector. So that's the comment for you. And for Vaibhav, solid waste is not my main area of expertise, but listening to your very compelling technological solutions, I was just wondering, technical solution is part of the problem, but implementation, having the institutional capacity, the governance capacity is bigger problem in India as I see it, because we all have to face it. We all know how to treat wastewater from various parts of the world. We have some successfully running wastewater treatment plants in India too, but still 70% of the wastewater is discharged without any treatment. So that's not a technical gap. Technology is there, but the problem is how do we actually now take it up and implement. So do you have any suggestions on how India could take up these fascinating technological solutions and actually apply and make use of them?
Yeah, in fact, that is very.
Should we hold it to the end
Yeah.
and let Robin comment, and then have both responses all in one go in the aid of continuity? That would be great. Thanks.
I'll stop here
Are you
now.
sure?
Yeah.
The,
Thank you.
I mean, what you've been saying, Meenakshi, feeds into what I would probably say, and again, jumping off Komali's remarks, the human element in any kind of technology is essential, and the governmental element is essential. And one of the dilemmas, I think, of waste management in India and also in Australia is the uncertain powers of local governments. They're probably more clearly defined in Australia, but nevertheless, local governments are charged with the responsibility for so much of waste management, particularly at the initial stages. And local governments in India simply do not have the powers either in terms of finance or the authority to execute a lot of the things that need to be done to begin to process waste in the ways in which the technology would allow. Also, local governments are underpowered in human terms. It's not fashionable for a clever person to go into local government because it's an uncertain and rather suspect kind of career. If you told your parents you wanted to become a local government officer, they would look at you askance because you'd end up in the state civil service and not even in the Indian administrative service if you were going to go in that direction. I think in Australia it's a little bit different. But the point in all of this is that it's the grassroots element, particularly in water management, that is so essential, and that's where the human factor comes in. The other thing I thought of as we were all talking, and again, and actually this goes back to what you were hinting at, is the danger that desperate local governments in Australia, but even more probably in India, want quick technical fixes. And the kind of most humorous one that I'm aware of is about 4 years ago, Trivandrum, Tiruvananthapuram in Kerala, the local municipal council was desperate for a solution. They had satyagrahas going on at all their landfills because the villagers in the surrounding areas no longer wanted or would permit rubbish to be dumped there. So the council bought or leased what was going to be a mobile incinerator, which was a great long monster of a thing, 35 meters long, towed by a Tata truck, that was going to burn garbage from locality to locality. And of course, it was an absolute fiasco, and it ended in all sorts of recriminations, and it didn't work. Now, that's an extreme example, but councils in Australia are also, I think, very interested in incineration. Incineration does so often seem to be the answer to all this. We just get a very flash, new, high combustion incinerator, and we burn it all, and our problems are solved. And there's probably a place for incineration, but it's only in special circumstances. And the final thing, it comes back to the water question that you all were raising. Sewage treatment plants are expensive, they're hard to manage, and what we really need, the ultimate tech solution, we need the perfect toilet. No one has yet devised the perfect toilet, which is a standalone, clean, easy to maintain, cheap, and without the need for any kind of external connections, toilet that will deal with human waste. And there are models that are getting close, but they're expensive, they're fussy, they may require a certain amount of space, but what we need is something that's as small as a small fireplace, will accommodate human waste, and maybe at the end of every week leave us with a bag of degraded material that you just pull the drawstring on and someone comes and collects it, and it goes on to become wonderful fertilizer. Because every kilo of fecal matter is full of energy. So if we're looking for the next high-tech solution, it needs to be the perfect toilet, but I don't think anyone anywhere in the world, a lot of Gates money has gone into looking for the perfect toilet, and they haven't done it yet. So those were my thoughts. If Komali, if either you or Vaibhav can devise the perfect toilet in your lab, so that'd be great.
Okay. Start with Yenneti first. You said, how can we implement these technologies without any governance or the policy for encouragement to actually sort of implement them? And that's very true. And in fact, this is one of the points which I think we are addressing right now. So India does have e-waste policy which was again revised in 2016, the e-waste management rules, and it is in some ways it is a comprehensive policy, in some ways it is not. There are certain drawbacks to that policy, and which again comes back to your question of implementation. There is no onus on, no responsibility on the people or the manufacturers who produce e-waste, even though there's no penalties for the defaulters that have been outlined and things like that. So that is something which has to be addressed. But one thing which we've found so far is economic benefits is by far the biggest driver in whichever economy you are in, whether in India, whether in Australia. The economic benefit is one of the biggest drivers for people to enter into implementing such kind of technologies, and this is why we also do what we call as financial modeling, do a basic financial modeling for our industry partners. Then they do their due diligence, and which again we do for people who are interested in India as well. And slowly but steadily there seems to be a change happening in India, especially after the policy that the government has come up with, the e-waste management rules. And so there are certain things which you no longer probably will be able to get away with, and things like that. But I think the driving factor in terms of implementing these technologies is what sort of economic benefit can a person or industry get. And with these technologies, the investment in it is not like if you want to set up a big smelter for metals and things like that, the investment is huge. If you want to tackle actually the low value waste of like plastics, the investment is really not that substantial. So that is one of the things, and can be operated by, you don't need a very skilled operator to operate these kind of things. So very suited for a demographic. So yeah, does that answer to some extent?
Yes, I think that's right, because having policy is one thing, but then providing that clear economic driver perhaps will put it a little bit ahead of the game, and you perhaps need to work at that level as part of the project planning. That technological solution is one thing, but enticing the right group of people who can make that decision and
Right.
take it forward.
In fact, Haripriya Rangan and Professor Rangan from Melbourne and I are all working on a very short policy brief that's actually titled Engineering India's E-Waste Policy. So we are addressing the things that you have said here. So
Sure.
hopefully in the next couple of months we should be able to
Great.
release that. So yeah, and yeah, I think Robin's question were quick technical fixes. I think I can comment on that. So yeah, so absolutely everyone wants a quick technical fix and wants to make money out of it. So by no means this is not a quick technical fix, but it is certainly not a complicated fix. So we can definitely provide this type of technology, the training required to set up these type of technologies in India to a great extent.
I think what you're saying, Vaibhav, is so kind of on the money. The people who did the first sort of academic studies of garbage in the States at Phoenix University in Arizona wrote a book called Rubbish about 30 years ago, and that was one of their lines. Waste gets managed when somebody makes a buck. There has to be a little bit of return for everybody in the process, from the person who picks it out of the garbage and separates the electronic from the vegetable matter, right through to the people at the top. And everybody has to make a little bit of a margin, otherwise there's no interest in doing it. Even the householder has to have, if it's domestic waste, either a carrot given to them or a stick held over them to separate their waste, to put it in the proper way, and so on, so that it becomes easier for the next stage to do something profitable with it. But that's cultural change as well as technical change. Technical things can make it easier, of course, and make it more effective.
Yeah, I think I'll just touch on the point of what Vaibhav was saying in terms of the waste, and also picking up on your, maybe I'll just start with the waste and then come back to Akshay maybe. So one of the examples that I don't know how many of you know, again, in Singapore, is widely globally seen as one of the best practices in waste management. They use incineration, but in a way that incineration, the ashes from the incineration is actually used to create a landscape.
They make Samacau Island out of it.
Yeah, so in a way, so there's a it's multiple benefits over there. So one way is incinerating. Yes, it is in the solution, but at the end, then that is being used in a way that there are co-benefits from the solution. So I think that sort of innovative, again, solution strategies are required, and not just technologies. So I think technologies and governments and governance should closely work together. And in terms of wastewater, we at UNSW, Professor Katie Bridge, in our faculty, she works closely with Karoma, the
yes,
you know, Karoma,
yes,
yeah.
yes.
So
The
toilet
ceramic,
maker, yeah,
toilet
the
maker.
ceramic toilet makers in Australia, the leading toilet
Yes,
makers in
yeah.
Australia. So last week we actually had a panel discussion with Karoma on this thing, and and this is a big project that we're doing currently in terms of, we're already working closely in terms of developing toilets for the special needs people, and also accessible toilets. One of the main things. But also there are other innovative things happening around in this space to use more and more better improvised accessible toilets, and also almost like the ideas that you were providing. So there would be at some point of time, we're hoping that it would be a solution. Again, picking on that, in Singapore, again, they use water from the toilet to be translated into drinking water. I don't know. We won't be comfortable, but yeah, that's what they're doing.
The cultural thing is interesting, isn't it? Because in Queensland, about 10 years ago, the mayor of Mackay lost her seat, or lost her mayoralty, when she proposed that they recycle black water, toilet water.
Yeah,
And people were so outraged. And yet in Singapore, new water is there on sale in the bazaar. And London's been drinking its own urine for more than 100 years.
Yeah,
so
I think
in a kind of recycled way.
So
Yeah.
that's
It
again-
connects to water, right?
Yeah.
So that's the reason I wanted to pick on the water point last. That I think yes, water is a major issue currently, and we know already. We have seen what happened in South Africa recently. Actually, one of my friends was there during this whole issue, and he's there for 3 months, and every day he was only taking a shower for 30 seconds. Literally, the water stops after 30 seconds. So that's a big issue. Yes. Just coming back to the point in terms of how linking it to urban heat. Yes, water sensitive, that's where I think water sensitive urban design comes into picture, integrating different forms of urban design itself, like using water permeable materials, water permeable bioretention pits, or are they using even rainwater tops? I know I didn't need to tell you, but there are a number of initiatives that are coming worldwide in terms of integrating water sensitive sort of design into cities. And one of the main thing is also linking it to these sort of green roofs and vertical gardens and other things. So there are a number of, in the recent years, there's a lot of research, but also being applied research and projects being carried out using native species that use less water and can take more water, so it can be sort of used when required. So I think there is an increasing need to integrate such kind of more technologies into city design that can both urban heat mitigation and water permeability can go hand in hand, not just one the other, but yeah.
Yeah, so I think the solution is to move away from the linear pathways for water management and sort of use it once and discard it. You perhaps need to be looking more at stormwater harvesting and recycling. So you've heard the reaction of waste to potable, but waste to non-potable perhaps is still the way we can make things and close the water cycle loop.
And also like in China there is a recent initiative, Spawn Cities. Know that many Chinese, some of the Chinese are not really happy with that, but I think it is a very innovative kind of solution that integrates all of these in one sort of urban planning and urban space making. So that sort of initiatives could be maybe the future. Yeah.
That's a good moment to interject as we have 10 minutes left and I wanted to have a chance to take some questions. So maybe we'll take a couple of questions and then answer. Yes?
In the recycling of the waste, we also face the issues, the waste getting dumped. Like we have seen the e-waste being recycled in India. A lot of waste also getting dumped in India for recycling.
Yeah.
Now, I heard your suggestion on recycling few things, but the research needs to focus how we can reduce the e-waste being generated. So one of the key things being proposed and discussed some time ago, that why can't we talk all the gadget makers to have a standardized for charging devices or some of the standardized thing, so that the e-waste generation of e-waste is reduced.
So is reducing the amount of stuff that we produce in the first place the answer to
Correct.
making India's environment cleaner? Can I take two more questions and then you can kind of broadly answer the questions at the back here? And
My question is to Vaibhav. Thanks, that was a really good, interesting presentation. I was wondering, following up from some discussion later, I was wondering if there's a market for private players to get involved, considering the economic incentives you say that the waste processing itself holds. Just about a day or two ago, there was a Supreme Court judgment about making social media complaints about pollution. So obviously there's a will to do something about it. So maybe it's a good time and space to actually get licensing for private players involved.
and just one last question at the back here and then I'll let you answer.
My question is again to quite an interesting point you made about not reinventing the wheel. So I just wanted to ask, when you talk about managing e-waste, so for example, Scandinavian countries like I guess Sweden or Finland, one of these, they have a very efficient procedure to take the e-waste and extract metals and quite a lot of stuff. So what are the hindrances or obstacles in trying to collaborate with them and using that technology in India?
I'll start with you, sir. So yes, that would be ideal if the manufacturers do indeed agree to create a similar type of charging device or things like that. Unfortunately, that doesn't seem to be the case because each and every one of the manufacturers would like to have a different selling point, which is,
Government policy initiative
Yes.
can come into play here, and research can come into play.
absolutely agree with that. Robin, would you like to add something?
Yeah, I think government policy, my mind in fact was moving towards the question of private interests in the profit aspect of this. And certainly in India, much less so than Australia, there's a very small corporate interest in waste. In the United States, there are two Fortune 500 companies, Waste Management and Republic Services, which are both in that top 500 for annual turnover, are waste management companies, and they deal in all aspects. But they began primarily by managing landfills and garbage trucks and taking money out of taxpayers for collecting their waste and dumping it somewhere, which isn't very productive. But I think the better companies are environmental. They try to style themselves as environmental managers. And then in India as well, it's NGOs who do a lot of interesting work in trying to benefit their local communities, but also create products that are useful and will make some money to help the whole operation run. But if we're talking specifically about India, that private enterprise, private industry aspect hasn't come. There's small-time criminality, unlike America and Italy, where it's big-time criminality and garbage very often. So, but India, it's more local criminals, smaller criminals rather than bigger criminals. So there's obviously money. If there's crime involved and great corporates, somewhere there's a buck to be made.
In terms of that's very true, but in terms of the private players, and especially after these management rules have come up, so there's now a clear procedure that's been outlined, and what we call as the producer responsibility. So you can actually apply for that license, and there's clear guidelines that are mentioned in the policy that okay, if you want to process e-waste, you have to do these sort of things. And currently in India, there are 167 registered e-waste recyclers, but not all of them are operating at capacity. If they were operating at capacity, it would be a much nicer picture. But there are certain private players, like a company called Atero, that is actually using technologies similar to what countries like Belgium or companies like Umicore are using. They're doing it on a smaller scale. So definitely the private players are interested in it, given the amount of licenses that have been issued in the recent past, and that will be probably be one of the dominant players. In addition to the government, of course, there was a recent article which said in Bangalore the government is actually establishing an e-waste recycling center, probably the first sort of an initiative by the government to do that, and that's coming up in Bangalore. But they don't mention what technology they're going to be using. But certainly private players are playing an increasingly important role in that, just looking at how many approvals have been given.
Can I just add to this?
Yes.
I have done a lot of work on private sector on waste management in India. Unfortunately, the answer is no, because there's simply no money to be made. My role as an industry player, half my company's wealth has come from consulting fees from this sector. I always keep saying that my clients should have got so much money, probably they would have made and seen a lot of cleaner India than our fees what we made. But the challenge is that there's absolutely no business model in waste, simply because it is not what we call in urban sector. It's not a revenue center. It's more a cost center. We have to keep pumping money, and we don't see, because challenge is more environment rather than making money out as a business. And it's been proven consistently across the sector last 15 years, whichever city you pick in India. But interestingly, the last project which I worked in Bombay was a waste management technology neutral bid. How do we actually handle that? 6 players, all international applied. I mean, we asked only international players to be the lead there. Everyone came with a mass burn incineration technology as the option. Everyone wanted incineration. No one wanted any other mode of treatment. And that's the way it went on. But unfortunately, because the tipping fees were very high, city never went ahead with the bidding process. But that's it. That's a deal in waste, actually.
Yeah.
See, that's the thing about, if you use incineration, there's probably not much money ever going to be made.
No, any technology you take, because
that.
higher technologies cost more. I mean, city simply doesn't have the money to pay. Whatever we do, they're not able to pay that.
Yeah, that's one way to look at it. Yeah.
Komali, I don't know if you have anything to add on those 3 questions, and otherwise I wanted to abuse my position as speaker and just go back to this slide that I had at the start. So I wanted to ask Komali specifically, because she's talking about smart materials and heat islands in cities, and how various ways in which cities can be made cooler. I was just wondering whether that technology also can be used to make cities less polluted.
Indeed,
And whether you can say something on that quickly before.
Yeah, sure. I think it's most of these. Yeah. No,
Yeah.
go ahead. No, yes, indeed. Actually, most of these technologies actually are, the core benefits of these actually include a number of other things, including thermal comfort and also air pollution.
Yeah.
And for example, if you see that the green vertical gardens and green roofs are a major technology in this space, they have significant amount of potential for reducing air pollution. Unfortunately, there's not much research being done in terms of the impact of these technologies in terms of reducing air pollution,
Yeah.
but yes, there is.
Final word, final question to Priya.
Sorry, I didn't mean it to be the final question, but I just want to point out, the point that Vaibhav made about smart and the temporal context of smartness. And what I find really puzzling about contemporary sort of urban design approaches to climate issues is how little they actually look at what used to be called, vernacular solutions to those problems. And if you look at parts of Pakistan, Iran, one of the most wonderful, simple technologies for keeping your places cool were wind towers, wind chimneys in people's buildings. Right on top there's a traditional technology there. We spend vast amounts of money doing air conditioning and then saying, let's get green plants and then let's pump water and, so the water issue isn't going to go away at all, given that we have, in most cities in India, you don't get 24 hours water. You have very limited amount of water supply. So I really think that it would be great to see some level of smartness being deployed in terms of using vernacular technologies in new ways, and that I'm not seeing happening.
So just to add to that, there is value in greening the cities, there is value in capturing the stormwater, there is value in reducing the overall water demand, because all that consumes a lot of energy as well. So water, to produce water, you need to pump water from somewhere, you treat it, you transport it, it all takes a lot of energy. So anything you can do to reduce water demand reduces energy use as well, and that in turn leads to reduction in CO2 emissions. And that means you can make the air less polluted if you are reducing that. So just by reducing the demand, by bringing less fresh water in the city, just by greening and providing the more opportunity for photosynthesis, so all the basic, back to basics solutions have opportunities to provide multiple benefits in terms of cooling the city, reducing water demand, and also making the cities less polluted.
So maybe it's a case of traditional tech rather than smart tech.
And
being the
integration and
solution.
interactions.
Yeah, I think that's I think it's a good way of sort of ending
Yeah.
the last way, that we need integrated solutions, not working solutions in silos. People
Yeah.
most of the time what happens is people working in, let's say, climate or urban stuff, or architects and designers and people work individually. Rather, I think it needs to be all of the stakeholders need to come and design cities in such a way that all of these solutions are integrated together, and that's the smart thing.
Yeah. Just one final, is it a brief comment, and then I'm
Quick
going to
one,
wrap
yeah.
up as
So,
well.
in mining industry, we talk about closed loop.
Yeah.
So when we start thinking about closed loop, then everything will fall into place. Yeah. So for example, having a universal charger is one way of looking at it, but also forcing the phone companies to use a certain amount of recycled metal within their semiconductors is the other way of looking at it. So it's just like if two majors like Samsung and Apple start using probably only 10% of recycled metals, it'll basically build up a huge market. And especially in minerals industry now, lithium is a hot metal, and people are already talking about green lithium. They don't want any nasty processes coming into their processes. So there's a lot of synergies between mining as well as e-waste processing. So I think there's some things which there should be a little bit more cross-pollination.
Great. Thanks very much. So on that note, we're out of time, so I'm going to wrap it up. But I want to thank our speakers and our discussants. That was a very stimulating conversation, I thought. I hope everybody had some interesting take-home message from the event, and please do come and ask our speakers.